Okay, for Mexican hairless dogs, hairless condition is dominant to hairy. All right, so hairless is dominant. We're going to give him the capital H. Put a little line indicating it doesn't matter what that other allele is. This is always going to be hairless. And to be hairy, give it small letters. That's going to be hairy. Okay, there's our legend. Okay, underline the parents. Step 2. What is the genotype of the parents? Well, we don't know the genotype of the parents. So when that happens, let's just put a line just indicating that we know nothing about these parents. But we'll just put the line in there. Of course, we can't do a Punnett square. Nothing to isolate the gametes. So now we're going to look at the steps we're going to go look at babies. All right, and at this point, we're going to look for, not look at ratios yet, but we're going to look for our Sherlock Holmes clue recessive babies. And we do have some recessive babies. So when we have recessive babies, that means we had some of these babies that were hairy. And we know that each parent must have contributed one of these alleles. Now, how do we fill in the rest? Go take a look at the ratio. Now we're going to look at the ratio. It says we have a 6-to-2 ratio, 6 being hairless, and 2 being hairy. Well, 6-to-2, remember we always have to reduce fractions, we always have to reduce ratios. If we reduce that, we know that 2 can go into 2 once, 2 can go into 6 3 times. We now have a 3-to-1 ratio. And this is a pattern that we should recognize. When you have a 3-to-1 ratio in a monohybrid cross, both parents must be heterozygous. So that's where we use the ratio to fill in the rest of the genotypes of the parents. And if you wanted to test that in a Punnett square, you can do that, but you will get that 3-to-1 ratio. Okay, any questions? Give me an email. Thanks, guys.